Welcome to another video on digital electronics. In this video we'll be seeing what is a JK flip-flop. So the drawback of an SR flip-flop was for S equal to 1, R equal to 1, the output that I used to get is undefined, and that to remove that we are now developing a JK flip-flop, which is a minor modification of an SR flip-flop. So it is made out of an SR flip-flop. So as you can see here in the figure, I have an SR flip-flop to which I am additionally adding two AND gates. So this is one AND gate, this is second AND gate. One input is J, second input is K. One input to the J AND gate is coming from this Q bar, and to K is coming from this Q, right? So this is the minor modification that we are doing for SR flip-flop, just to get rid of the final condition of the truth table. If you remember the truth table of SR flip-flop, see here the last line, that is 1 1, it is undefined. To remove this we are doing some minor modifications and naming this as a JK flip-flop. Okay, so what is the equation now for S? My S is equal to J into Q bar and my R is equal to K into Q. So by doing this connection, these are the new equations that I am getting. Now I have to develop a new truth table. So to develop a new truth table, again I have to consider what are my inputs and what are my outputs. So J and K are my inputs. Since I have two combinations of input, how many combinations are possible? 4 different combinations are possible. But here we have to consider one more situation for output as well. So Q initial state could be 0, it could be 1. I have to consider both the cases of Q. So in short, I will have 4 input combinations, and for every 4 combination I will have 2 output combinations. So in all I will have 8 different combinations. So let us come to the truth table. See here, this is the truth table for JK flip-flop, developing a JK flip-flop out of SR flip-flop. So initially I have considered 4 conditions. J is equal to K is equal to 0 0, then I have 0 1, 1 0 and 1 1. But I have written twice. What is the reason for writing twice? The reason is output. The initial state, the Qnth state could be 0, it could be 1. And now I am finding the n plus 1th state for the JK flip-flop, right? So if this is 0, this is 1, of course Q bar is going to be complement, it's going to be 1 and 0. Here also there is a possibility initially Qn could be 0 or Qn could be 1. So if this is 0 1, this is obviously going to be 1 0, 0 1, 1 0, 0 1, 1 0, right? So for every J and K equal to 0 0, I am considering both. My Qn could be 0 or could be 1. And for this Qn, I have to now find out what is new Qn plus 1, right? Okay, let us now find out S and R. How do I get S and R? I have the equation for S equal to J into Q bar, R equal to K into Q. Both those values are available to me. All the 4 values are available. I just have to multiply and get the answer. So S is equal to J into Q bar. So this is my column of J. This is my entire column of J. And Q bar. This is what you have to multiply to get your value of S, right? So I'll quickly write down the values. Okay, so I have written down the values. Now since the input to the flip-flop is going to S and R, now I will use this S and R truth table to get my values of Qn plus 1, right? So S and R I have, I will get the value of Qn plus 1. So if you remember the truth table of SR, for 0 0 it is Qn, 0 1 it is 0, 1 0 is 1 and 1 1 is undefined. Okay, so for 0 0, what is my output going to be? Qn plus 1 is going to be nothing but my Qn, right? So for 0 0, it is going to be Qn. So it's going to be 0 and 1 here, 0 and 1. So for 0 0, this 0 0 also I will have 0. For 0 1, my output is 0. For 1 0 my output is 1. For 0 0 my output is Qn, which is 1. For 1 0 my output is 1, and for 0 1 my output is 0, right? So this is the output that I am getting. Okay, now by doing this crisscross connection, what we are doing is we are eliminating this condition of S equal to 1 and R equal to 1. Look at this table. Can you find any state where S and R both are 1 1? No, which means we have tried to eliminate that state, and hence I have eliminated the undefined state of Qn plus 1. Now if I have to write combined table for Jk for these 4 values, let us see how we can write. This is 0 1, which is same as Qn. If you see here, this is 0 1, which is same as Qn. So my output here is going to be Qn. It's going to be same, right? For that is for Jk equal to 0 0, right? For J and K equal to 0 1 and 0 1, no matter what my input to S and R goes, my output is always 0. So here my output is going to be 0. Similarly for 1 0, no matter whatever goes at the input, my output is going to be 1 1. So it's going to be 1 1 in this state. And lastly for 1 1, for 1 1, whatever I have at the input, see my Qn plus 1, if I compare with Qn, my Qn is 0, I am getting output as 1. Here it is 1, I am getting as 0, which means it is complement of Qn, and hence I will write here Qn bar. So Jk truth table, if you try to get a Jk truth table from here, the compressed version of it, how will I write it? J equal to 0, K equal to 0, output is Qn. So Jk Qn plus 1, 0 0 0 1 1 0 1 1. For this it is Qn, for this it is 0 1 and Qn bar. So this is how we have compressed this output of Jn and Kn, and this is the truth table for Jk flip-flop. What have we achieved here? We have achieved this Qn bar by removing the undefined condition of SR flip-flop. I hope this is clear. I will stop the video here. Thank you.